Good morning, everybody. We're talking about solution intervals to a floor equation today. And let's take a look at why we would expect solution intervals, ranges of real numbers. For example, the floor of 6.8. Floor of 6.8, according to the definition, and it's pretty easy just to see this without resorting to a formal definition, but it's equal to 6. But the formal definition says that's true since 6.8 is less than or equal to or is greater than 6, and it's less than 7. Okay, so you see the floor function actually defines an interval of numbers length 1. Okay, now let's take a look at another example. Let's say this, now this part is a little confusing perhaps. Let's take a look at the floor of minus 6.8. Now this is a little backwards. It took me a while to adjust to this. It's simple, but I don't know, it bothered me. This is actually equal to minus 7. And it just has to do with the geometry of the real number line, I guess. That's because minus 7 is less than or equal to minus 6.8. Is less than minus 6, right? So that's the way it works. It's called the greatest integer function. And negative 7 is the greatest integer less than negative 6.8. It's the same thing. It's just how the minuses go in the opposite direction. So that's what's going on. Now let's take a look at how we might solve this. This is the absolute value of a linear function. The absolute value is always positive, right? So you can anticipate solutions that are negative and positive. Now the rest of this is just literally the absolute value of the linear function x minus 13/12 is equal to x minus 13/12. And I'll just write this out to the side. When x is greater than or equal to 13/2. Okay, this statement is true as long as x is greater than or equal to 13/2. X minus 13/2 is non-negative. And that means its absolute value is itself, okay? Y'all, and the rest of this is just really just fractional arithmetic. Notice that 5 is the same thing as 60 over 12, right? 5 is the very same thing as 60 over 12. 60 divided by 12 is the fractional equivalent with a denominator of 1 of 5. 60 divided by 12 is 5. So that's where we get the 73 right here. And then similarly, 6 is the same as 72 over 12, right? 72 divided by 12. Okay, and that's when you add, so when you add 13 to 72, you get the 85. So you get this as one of the solution intervals, folks. You can write this in a more compact form if you want to. You can write this as close brackets 73 over 12. And then comma 85 over 12. Non-inclusive. Now, y'all, if you don't trust this, notice that actually, let's see here, 84 over 12 is 7. So 7 is in this interval, right? 7 is contained in this interval. 7 is in here. And you can go back and check to see that 7 works here, okay? If you did 7 minus 13 over 12, that would be what? 5 and 11/12, which has a floor of 5. So again, 7 is an integer value in this interval that you could check if you want, all right? Now also in a very, very similar fashion, I won't bore you with all the details, but this would happen if x is less than 13 over 12, or 13/2, excuse me, less than 13/2. That should be 12 up there, shouldn't it? Okay, 13 over 12. Okay, and again, that just follows immediately from the definition of absolute value. I'm off the screen here, but if x is less than 13 over 12 right here, this would become negative, so the absolute value has to be positive. So you have to flip the signs down here, which is what we did. Okay, we have 13 over 12 minus x, not x minus 13 over 12. And again, it's just this definition of absolute value. All right, and again, all the work is very, very similar. The one thing that's a little sneaky is when you multiply through by a minus here, you have to reverse the sense of the inequality. Notice how here this is less than or equal to, you multiply through by a minus and you reverse the sense of the inequality. And also notice that 4 is in this interval. Now let's go ahead and, if you want to write this in interval notation, it would be minus 59 over 12. Because that's a smaller number, right? On the negative side. Comma, minus 47 over 12. And this would be bracketed. And you can check that 47 over 12 would just lead to an integer value in the original equation. Okay, so that's the solution, folks. Also, just notice that minus 4 is a member of this set. Minus 4 is a member of this set. And if you go back up here and check minus 4, you can see that it works fairly quickly. Minus 4 is 48 over 12. Minus 13 over 12 would be minus 61 over 12. But that absolute value of that would be 61 over 12, which would have a floor of 5. 61 over 12 is just 5 and 1/12. So again, it's easy to check these, but these green answers right in here are the solution, and I hope you enjoyed that.